We're doing our presentation today on Apache Cassandra. I'm Brad, and I'm presenting with Apache. Many of today's web, mobile, and phone applications need to meet new demands that many previous databases did not have to. Databases today need to be able to handle large amounts of concurrent users, always be available, deliver quick and timely responses to users across the globe, all while handling a multitude of traditional and non-traditional data types. In response to these growing demands, NoSQL databases emerged as an effective alternative to traditional relational database management systems. Whereas relational database management systems have a fixed schema and need structured and organized data with rigidly defined data formats, NoSQL allows for a more flexible schema that can handle unstructured and unpredictable data types, all while being less expensive and easier to scale. One of the most powerful NoSQL databases that currently exist in the market is Apache Cassandra. Apache Cassandra was developed by Avinash Lakshman and Prashant Malik while they were at Facebook. It was initially developed to power Facebook's inbox search feature. Facebook released Cassandra as an open source project on Google Code in July 2008. In March 2009, it became an Apache incubator project, and in February 2010, it graduated to a top-level project of the Apache Foundation. One of the biggest reasons organizations utilize Apache Cassandra is Cassandra utilizes a peer-to-peer distributed system in which data in Cassandra is distributed across various independent nodes in a cluster. For example, in the image to the right, each orange circle would represent an independent node within the ringed data cluster. With the same data spread across various nodes, Cassandra has no single point of failure. Even though each node in a cluster is an independent data source, each node is interconnected and regularly communicates with other nodes within the cluster. When data is stored in Cassandra, one node stores the data and another or multiple nodes act as a replica for that given piece of data. For example, node 1 would initially receive a piece of data, and that data would be replicated to node 4 and to node 5, or all nodes based on the replication formula. In this way, if node 1 were to fail, the replicated data in node 4 and node 5 can supply the required information to the user. A similar process occurs to keep data up to date in Cassandra. If node 1 were to detect that the data in node 4 was old, node 1 would rewrite and update node 4. Cassandra automatically performs these repair and update operations to keep the database up to date. Other selling points of Cassandra are its ease of use, ease of upgrade and maintenance, as well as Cassandra's ease of scalability. Out of the box, Cassandra is a straightforward system to administer. As we previously mentioned, data in Cassandra is shared and replicated across nodes. This happens automatically without any additional programming. An added bonus to the independence of nodes in Cassandra is that Cassandra can support the planned or unplanned loss of multiple nodes without any impact to the overall performance of the cluster. This is extremely beneficial to companies who need to do maintenance and/or upgrades but can't suffer loss or performance outages. With all of the nodes being the same, additional nodes can be added cheaply, easily, and with predictable increases in performance. For example, if 2 nodes handle 100,000 transactions per second, increasing to 4 nodes will increase transaction capacity to 200,000 transactions per second. If we were to add 4 additional nodes, we could process 400,000 transactions per second.
One of the stronger features of Cassandra is its ability to utilize tunable consistency. There are 2 types of consistency: strong consistency and eventual consistency. So strong consistency is the ability to guarantee an update is propagated to all locations where that piece of data resides. In a single data center setup, this would guarantee that all of the servers that should have a copy of data will have it before the client is acknowledged with a success. In terms of performance, this usually means a cost of few extra milliseconds to write the data to several servers. Second is eventual consistency, means that the client is acknowledged as soon as a part of the cluster acknowledges the write. In one case, a single server could acknowledge receiving the data and begin propagating the data to other servers immediately. This use case could be best when application performance matters the most. Data are replicated to other machines immediately, and, and this is especially useful for replication across wide area networks. Because Cassandra offers tunable consistency, the choice is yours for stronger or eventual consistency. You can mix and match them. You could use strong consistency for a local data center with eventual consistency to a remote data center. Cassandra offers the flexibility and power to satisfy any business needs your data store. When should Cassandra be used? Apache Cassandra can be used for various applications. Here are some use cases where it would be the best choice over other NoSQL databases. In activity tracking and monitoring applications, numerous entertainment and media organizations use Cassandra to monitor user activities based on movies, music, albums, artists, or other parameters. Second is in heavy write systems or in time series based applications. Cassandra is perfect for very heavy write systems. It turns out that writing data in each point individually is very expensive. In other words, touching every row every second is very expensive load pattern. So Cassandra decided to buffer the data in memory and write multiple points for each time series in a single batch statement. Now hold on to this batch statement. We'll talk about this in a few minutes. Third is social media analytics. Cassandra is used by many social media providers to analyze the data and provide suggestions to their customers. Fourth, product catalogs and retail applications. A very popular use case of Cassandra is to display fast product catalog inputs and lookups and retail applications. Fifth is messaging. Cassandra serves as a database backbone for numerous phones and message provider applications. Now, the major companies using Cassandra. First, the father of Cassandra, Facebook. Facebook used Cassandra to power inbox searches. Second, Twitter. Twitter uses Cassandra because it can be run on large server clusters and is capable of taking in very large amount of data at an individual time. Third, Netflix. Netflix uses Cassandra as their backend database for their streaming services. Fourth, Cisco. Cisco is a lot into networks and security, so it uses Cassandra to store user feed and activity in real time. Fifth is SoundCloud. SoundCloud uses Cassandra to store user account information. Here are a few other companies that uses Cassandra. First is Accenture, there is HP, there is IBM, there is Tapit, and there are a lot of more other companies you can see here that uses Cassandra for various reasons. Now let's talk about the Apache Cassandra query language. It is very similar to SQL. It was first introduced in Cassandra 0.8. So in Cassandra query language, you can create tables, insert tables, and use many other features. It also supports JSON, user-defined functions, user-defined aggregates. So if your application has a large amount of data and if you're planning to scale it, then Cassandra will definitely help you. The main reason and the difference between relational database and Cassandra is that the former divides the data into multiple tables, whereas Cassandra tries to keep it as intact as possible so that you can avoid using joins to retrieve the data. Now let's dive more into the SQL. Key space. A key space in Cassandra is a namespace that defines data replications on node. A cluster contains one key space per node. Given below is the syntax for creating a key space. So you create a key space, write the name of the key space with the replications. Now let's talk about replication. Replication option is to specify the replica placement strategies and the number of replicas wanted. There are three types of replica placement strategies. First is simple strategy. Specifies a simple replication factor for the cluster. Second is network topology strategy. Using this option, you can set the replication factor for each data center independently. Third is old network topology strategy. It is basically a combination of the above two. Here I'm again creating a key space demo DB with replication. I'm naming it and specifying network topology strategy data center, and the number of replications is 3. And in the next line, we are just altering this key space. In this slide, you can see that creating, inserting, and selecting a query in Cassandra is very similar to SQL. Just have a look and read for yourself. SQL batch. We spoke about this in heavy read and write systems. So in using SQL batch, you can execute multiple modification statements simultaneously. So suppose you have an employee table where you have to insert a new employee, update a particular column of a particular employee, and delete a particular employee. So you can write all these statements in the begin batch and between the begin batch and apply batch, and then execute it simultaneously. So this is all we have to talk about from our side about Cassandra. Hope you liked it.